Hi, everyone. Welcome back. We are about to start the second case study in our course, Introduction to Machine Learning in Portfolio Construction. So this case study, which is titled Understanding Shapley Values for Feature Importance, is building on what we did in case study number 1. All right, so this is a continuation. And that's what we're going to do here is we're going to dive deeper into feature importance and specifically how we can use Shapley values to help explain our models and figure out why our models are doing what they're doing. So let's just start right away here with the typical, like the way we start everything. We love to start with a summary and tell you why it's important. Okay, so first and foremost, what's going to happen during this course? We are going to continue what we did with our hierarchical clustering results. Now we're going to add on some other machine learning techniques. Specifically, we're going to use a gradient boosting technique called light GBM, which we will use to then assign the funds to clusters so that we can create a model. We can create a supervised learning model that will essentially try and predict which cluster a fund should go in based on its features, on its factor exposures, the risk and reward exposures, and then we will use Shapley values to interpret why they are being put into each cluster and how the clusters, what features were important for determining which funds would go into which cluster. Because as you remember, the way we finished off the last one, we did not say why the model assigned funds to those clusters. And that's what we're going to tackle here. So why is this important? Well, using the Shapley values will allow us to get this understanding, will give us the clarity of understanding why the model put funds into each cluster and which features were responsible for it. Why is that important? Well, if you knew which features were most important, well, then you could make decisions based on those features. Let's say you can say, well, I'm most interested in this risk metric, and I want investments that are going to do well with this risk metric. This will help you decide that. Normally, we want to use not just one. We usually combine it with a number of metrics. So you can use the Shapley values to help isolate the funds that will give you what you are looking for. And that's what we're trying to do here. All right, so how are we going to do this? All right, so it's essentially, three ways or three things that we're going to try and get done here. One, we're going to use the clusters that we did from case study 1. All right, so this is just really the very brief outline of what's going to happen here. Then we're going to determine the feature importance and how the model responded to all of the funds that were in there. And then once we've decided on this, once we figure out the feature importance, then you can move on and rank funds or asset classes based on what you're looking for, your specific, favorite criteria. And the beautiful thing about machine learning is now it's not just one, you have to eyeball it. You can combine multiple metrics together and come up with a scorecard or something like that. And that's really where we're going to with this, is eventually you being able to rank funds or your asset classes that will help you make the decisions of which ones to include in the next step, which would be portfolio optimization or just selecting them to build your strategic asset allocation policy. Now, again, please, if sometimes you might find that I'm going a little bit too quickly with these terms or something like that. The beautiful thing about the videos, you could always pause and watch them again. But at the same time, if you go back to the investment management workflow mini course that we gave you that sets the context and sets the environment, there's a lot of information about the flow, about the steps, the flow diagram. And, everything we are going to be doing is in context of one of those steps. And we are still in the strategic asset allocation phase here because we're continuing case 1. All right, so that's where we are in the investment management workflow. So just as a reminder, here's the dendrogram, right? So what we saw is we had 4 clusters. We decided on the 4 clusters basically because we drew that horizontal line at 8, and how many vertical lines we cross is how many clusters we get. Now, these clusters were created because of their similarities of the features, which were various, mostly risk characteristics and the returns. And this is for the single point in time. So we will be working with a single point in time estimate. That's what we did in the first one. And now what we want to do is why were the ARC funds placed here? Or what do all of these funds have in common here? What feature was responsible for creating this cluster here with 6 funds? And that's what we're going to do. And it introduces Shapley values. Shapley values are so incredibly powerful. And once you learn how to use them here, you will be able to use them in every single one of your other projects that involve supervised learning. And yes, I know hierarchical clustering is an unsupervised learning method. However, doesn't mean we can't take a temporary or an interim step of converting this to a supervised learning problem so that we can use Shapley values to help enhance the entire clustering process. All right, so that's the flexibility that machine learning has. So again, once you learn this, you will be able to use Shapley values for feature importance in any other project that you are going to use. And trust me, you will use these a lot. And they work. They work very well. Okay, so let's just immediately state our 3 objectives. 1, learn how to do gradient boosting. 2, learn how to generate the Shapley values. And then 3, interpret it. Interpret what you are seeing from the Shapley values to give you some insight into the behavior of the model. Okay, so let's just take a very high-level approach here right now. So what exactly are Shapley values? They're actually based on game theory. These are coming out of some work on game theory. Now, we're not going to sit here and explain everything about the Shapley values themselves. Again, this is much more about the practical applications of everything. We will be supplying various links that you can do for background reading. But you could even just go to ChatGPT and say, please give me a crash course in Shapley values. How are they used and how can they help me understand a model's performance? You'll get a phenomenal response just from ChatGPT with that. But in any event, so high level here, Shapley values are used to understand the model and which features were responsible for the model creating its output. Okay, that's what Shapley values are. In this case, we are trying to identify which features, was it standard deviation, Sortino ratio, Sharpe ratio, which ones were most important for that cluster and determining that cluster's makeup. All right. And how do we do this? Well, we've got 3 steps here, right? Well, we already have our feature matrix. Okay. So we're going to keep that feature matrix. And then we will assign a cluster number to each fund. We did that briefly in the first case study, but now we're going to be doing it through the gradient boosting method. And then once we have that, then we can apply the Shapley values. So that's the 3 steps. That's what we are doing here, is we're going to make use of the feature matrix we already have. Then we are going to assign the clusters, and then we're going to use a gradient boosting method to try and help predict which cluster a fund would be in. And then because that becomes a supervised learning model, we can then apply Shapley values. That's what we are doing. And I hope everyone is happy with that and that works for you. Okay, so let's talk very quickly about gradient boosting. So gradient boosting, has been around for a while now. This isn't anything new, but essentially what gradient boosting tries to do is we're trying to continuously reduce the residuals of a machine learning model, like the unexplained part. Now, gradient boosting, you could always, like the classic analogy of how gradient boosting works is imagine you're on a hill. And you're constantly measuring the slope of the hill and you're trying to get to the minimum, the bottom of the hill. And with every step or every 2 steps, you're going to say to yourself, did I go up or did I go down? If you went up, well, that's clearly not good because you're trying to get to the bottom of the mountain. So then you'll recompute your direction and try and keep going back down. So this way you'll get a feel for the local maximums, the local minima, until you eventually roll all the way down to the bottom of the hill. So that's what gradient boosting does. And it's a very, very powerful machine learning tool for both regression and classification. And of course, Python libraries are all set up for this. Now, the reason why we call this one light gradient boosting is because it's really a simplified version of it. There's like XGBoost. If you think of XGBoost, CatBoost, some of the most popular gradient boosting ones out there, this one's a lightweight one. Which is perfect for our tasks that we're trying to do here. You don't necessarily need to bring the most powerful gradient boosting model for a task as easy what we're doing here. So what we're going to do here because gradient boosting is supervised, meaning that you need to have X and Y's, targets and features. So the features are your X and your Y are your target. And the gradient boosting, again, is going to create a model that's going to try and predict Y based on your X's, going to try and predict the targets based on your features. So once we have that model, then you could use the Shapley values. So light gradient boosting is perfect for this. It's lightweight, and it's a very powerful machine learning technique because it does what I explained before with trying to get you to the bottom of the hill and recompute your slopes, which is the gradient. You can easily do some research on this. Again, we'll put some links for you together so you can do some extra research. But again, sometimes I find just going to ChatGPT and say, give me a crash course in this and ask questions, you learn very quickly. All right. So once we have the LGB and the gradient boosting done, what you can see with the graph here, this is going to give you an example of what we're going to see, towards the end, is it allows you to tell you, so we had 4 clusters, here we are, 0, 1, 2, 3, and it'll tell you which features that were used most by the clustering model in determining which cluster you went into. Right, so just for example, right, let's just take, I'll use the examples here in the text on the slide. Cluster 1, all right, the blue one, so here it's class 0, but we call, that's our first cluster. It's the 0-based indexing. What you're seeing here is that, downside deviation was clearly the most important for it. But then if you look at the red, we can see that, this was the category that had all the tech funds, semis, NASDAQ. We see that the Sortino was the dominant driver. So once we look at this kind of thing, you're going to be able to say, okay, you're going to be able to make some very good inferences from this information to help you understand the drivers of those funds in each category, in each cluster. That's crazy powerful. Again, think about the amount of information you are going to be armed with instead of just looking over your Morningstar Direct presentation studio reports where everything's separated out, one metric at a time, right? This just doesn't exist anywhere else. And we're giving you the power to do this on your own with freely available stuff. Now, how cool is that? All right. So this, the way we're going to use the Shapley values, right? We're not going to go through this on the slides here. We're not here to just read text or anything like that. But what I do want you to know about how we're going to use it for portfolio construction is to essentially look at the Shapley values, extract the most important features for each cluster. So it's going to help you decide which funds you want. And then you could even create a scorecard on them based on their Shapley values. You could actually start going through every single observation, figuring out what their features were, and then you could rank them based on the Shapley values. But of course, you will have to set your own scoring system, like saying, well, I'm most concerned in downside protection. Well, then you're going to focus on the downside deviation and the Sortino ratio. So you're going to be able to create your own scorecards using the Shapley values. It's also going to give you much better insight into your models. Like, for example, if you see that there's a feature that's not being used at all, then get rid of it. So yes, we've simplified it right now with 7 features, but imagine you had 15, 20, which I encourage you to experiment with down the road, is add way more things into this thing and see what comes out. So, you're going to get Shapley values from it, and then you'll be able to remove useless features and then run the model again, and you're going to get even better results because you've taken out some of the noise. So that's how you're going to be able to use it, and that's how you're going to be able to use it for portfolio construction. All right, we're stopping the theory here. We're going to dive right into the coding next. Get ready, get excited. I know you're going to have fun. I always do. Let's get to it.